Wash your hands, men. Okay, here's where things get a little more complicated. Polyatomic ions. So they look like this. That's just a list of very common ones. And on a test or anything like that, you would have a list of these so you do not have to memorize them. I would, however, write them down in your notebook so that you'll have them. So this is what they look like, and these are ions. Alright, so let's fill in the notes and then I'll explain a little more. So these are actually covalently bonded. Covalently bonded groups of atoms with a positive or negative charge. Make sure you're writing all this stuff down. You should be writing down everything that I do on all the videos. Alright, they are caused by the formation of an ionic bond with another ion. Alright, so they behave as a single unit. So, like this ammonium over here, this ammonium, NH4, and it creates a positive charge, NH4. That behaves as a single unit. So this stuff can never change. If it is ammonium, all those will always stay together, just like that. Okay, so they seem like a single element or a single unit, but if you were to look in closer, the structure is actually very complex. Alright, let's look at writing formulas like this. This part should not be too bad. Alright, sodium carbonate. So we're going to follow our steps from the last video. Sodium is right here. Remember, you're using oxidation numbers here, and group 1 has a +1 charge. So sodium is Na. It has a +1 charge. And then carbonate, here's the formula for that. CO3. And this tells me that it has a 2- charge. 2- charge. Okay, so we've written the symbols, we've written the valency, and now we have to cross over. Okay, so now we're going to have Na. Let me write it under it, that might make a little more sense to you. Na2, because of this 2, and CO3, and we have to keep that together. If I were to change this 3 right here, it would no longer be carbonate, and it has to be carbonate. So if you wanted to, and I would recommend this, I would keep this in parentheses so you know to keep it together. Alright, so then you would bring this 1 down here. And remember, if there is a 1, you don't have to write it because it's assumed. Alright, and that would be your answer. Na2CO3. Alright, you try these. Pause the video right now, pause it, and you try these 2 right here. Magnesium sulfate and calcium sulfate. Alright, you should have paused it. I hope you did. Alright, magnesium. Magnesium is right here. And if you have your oxidation numbers on your chart, which you should, it's a +2. So we got magnesium, then we got to go up here and find sulfate, and it is SO4. Okay, so we got step 1, write the symbols, then write the valency. So magnesium we said is 2+, And sulfate, if you look right there, is 2-. So that one is perfectly paired already. It created a balanced charge by itself. So that is just the answer, MgSO4, just because these charges are already balanced. All right, calcium sulfate. Calcium, it's right here, calcium. And then we got to go back over here and look at sulfate, which we've already written it there, so SO4. That is not a good example. Let's go with calcium phosphate. I think that may be what I meant to write. So let's change this. Phosphate. Pause the video. Rework it, please. Calcium phosphate. Pause it. Okay. Alright, so we got calcium and then phosphate is here. PO4. Alright, calcium has a 2+ charge. And I'm just getting that from right there. Calcium has a 2+ charge. And phosphate has a 3-. Okay, just cross these. So, Ca3, and then you got to keep all of this together. PO4, and then don't forget to bring that 2 at the very end. And that is your answer.